So, like, if you and I are in a spaceship and we're headed straight toward a black hole, like, what is that going to be like for us? Like, what's happening?
It's going to get weird really fast.
Our universe is a wild and wonderful place. And in this podcast, NASA is your tour guide. I'm your host for today, Jacob Pinter. In this episode, buckle up, because we're diving in to black holes. They are some of the most mysterious objects in the universe. Ronald Gamble will help us understand what we know about black holes and what's left to find out. We'll debunk some of the biggest myths about black holes. And we'll answer some burning questions sent in by you, the listeners. Ronald Gamble is a theoretical astrophysicist at NASA. Now, just to set the record straight, he hasn't actually been inside a black hole. No one has. But as a NASA astrophysicist, Ronald knows what's going on in there better than just about anybody.
A black hole is a region of space-time, right?
Yeah.
We know space and time, where the gravity is kind of so immense, where planets, stars, galaxies, smaller galaxies, even light, photons, can't escape out. And they are very, very complex objects, but they're very simple at the same time.
Now, we still have tons of questions about how black holes work. But thanks to physicists like Ronald, we're learning more about them all the time. Ronald is one of those scientists who is constantly surrounded by long strings of numbers.
The best way I can describe it research-wise is if you picture Einstein or somebody at a chalkboard writing all these equations, that's what I literally do all day. It's a lot of math, it's a lot of science, but kind of finding ways to mash those things together, physics, quantum physics, electromagnetism, space-time, relativity, all of that, all together kind of gives you an idea of what's happening around black holes.
The math tells us that as we approach a black hole in our hypothetical spaceship, we will pass a point of no return. Now, black holes rotate, just like planets or stars. And once we get close enough, we start to rotate along with the black hole. It's like we're stuck on some kind of interstellar merry-go-round.
So space-time is literally being dragged around. You have no choice.